Okay, today's lesson is lesson 3-4, multiplication and division equations. So in this lesson, you are going to use balanced equations and inverse operations like we talked about before. So you're going to want to make sure that your equations when you solve are balanced, and that whatever you do to one side, you do to the other. I can't write and talk at the same time. And that you use the inverse to solve it, okay? Oh, I spelled it wrong. S. There we go. Use the inverse to solve it. So to review what that means, and the inverse is the opposite. So when you have an equation that you multiply in, you are going to divide. And when you have an equation that you divide in, you're going to multiply. And the reason we do that is because we want to get that variable alone. Okay, so the goal, it's always the same goal. In algebra, it's always the same goal. We need to get the variable alone. It's easier if I write in cursive. Okay, so the properties and the vocabulary that we're talking about today is the multiplication property of equality. So this multiplication property of equality essentially says what this is right here. When you multiply each side of an equation by the same number, it produces an equivalent equation. Okay? Actually, this would actually probably be, oops, I goofed that up. No, I erased it all. That would actually be this one right here. That when you're dividing, you're going to multiply on both sides to get that variable alone. Okay? So if you do it on both sides, it's the multiplication property of equality. It's essentially what makes it legal. On my symbolic transformations wall, that's called the multiplicative property of equality. Okay? Now, there's also the division property of equality. And the division property of equality says that dividing each side of an equation by the same number produces an equivalent equation. So that would be this. When you have a multiplication equation, you're going to divide to get that variable alone. Okay? That's what that all means. And that's essentially you're doing the same thing that we did before, except that you're going to use different operations. So, and you need to make sure that it looks right, you know, that you're doing everything that you need to do. So this first problem that we're going to go over is this problem right here. X over 3 is equal to a negative 6. Okay, so what this is saying is that when you have x and you divide it by 3, because that fraction bar means divide. So when you have x, you divide it by 3, you get a negative 6. So to solve this, you have to multiply both sides by 3. So you're going to take x over 3 times 3 equals a negative 6 times 3. Okay? Because over here, and I want to kind of explain what this looks like, that 3 times x over 3 is, and I'm going to write this over here kind of on top of what they have, it's 3 over 1 times x over 3. I just want to show you what the multiplication property of equality means. So, right, because we're setting it up kind of like a fraction. So 3 over 1 times x over 3. Well, these two, if you cross simplify, those become 1s. So you're left with x over 1. And x over 1 is going to be equivalent to x. Because any number over 1 is that number, no matter if it's a number or a variable. So because of that, when you multiply both sides by the number that you're dividing by, you're going to end up with just your variable. Okay? And then you end up with a negative 6 times 3, and that would be a negative 18. And then if you wanted to check it, you would take that negative 18 and you would plunk it back in for here. And if it works, then you did it right. And if it doesn't, then you did it wrong. Okay? And then you got to go back and fix something. Okay, so let's also go over the next one. The next problem is B that we're going to go over. And that's 18 equals a negative 4y. Okay, now When you have a number right up tight to a variable, that means multiply. Well, the inverse of multiplication is division. So I use those fraction bars to show division. And you're going to divide both sides by -4. The reason you're dividing both sides is you want to keep it in balance. You don't want that teeter-totter to go off to one side. And you want to make sure that when you are multiplying that, or when you're dividing, that you are dividing by the number that's with the variable. Because the goal, again, is to get that variable alone. So now, what does this mean? This means that if I have a -4y over 4, -4, sorry, that means that it's -4 over -4 times y over 1. Okay? -4 over -4 is equal to 1 times y over 1. Well, the identity property, the multiplicative identity, says that when you multiply any number times 1, you get that number. So that's going to equal y over 1. And we just said that any number over 1 is that number, whether it's a number or a variable, so it equals y. So this is why what we do works over here. That's why we are dividing both sides by that -4. And it really is because of that multiplicative identity and the division property of equality. Okay? All right. So over here then, like I just showed you, we're left with y equals, and 18 divided by -4 is a -4.5. And it's not always going to come out perfect. Math isn't always perfect. Sometimes it's messy. So don't expect it always to be perfect. But what you can do to check it is you take this 4.5 and you plunk it in here, and you see if that works. It's -4 times a -4.5, 18, and you will find out that it is. Okay? All right, what I would like you to do is I would like you to pause your computer, and I would like you right now to do number 1 and number 3. Pause your computer, do number 1 and 3, and then come back. Okay, number 1 and number 3. Number 1 is x over 5 equals a -2. So that's x over 5. And I would want you to rewrite this step. And you're going to multiply both sides then by 5. Okay? Now over here, like I showed you up above, those are going to equal 1. So then you're left with x equals. Then a -2 times 5 is going to be a -10. And essentially that's how your work should look. Okay? Maybe not as sloppy as mine because of the pen and the mouse. Okay. So then we have 3 equals a -1.5n. So it's 3 equals a -1.5n. Now we're multiplying here. Number right up tight to a variable means multiplication. So we're going to divide both sides by the number that's with the variable because we want to get that variable alone. So we're going to divide by -1.5. Okay? Over here you're left with -1.5 over -1.5 is 1. So you're left with n because n times 1 is n. And then 3 divided by -1.5 is a -2. Okay? All right. If you got those both right, you can move on. If not, you should rewatch so that you understand where you made your mistake. Okay, so the next type of equation we're going to have is an equation where you have a variable times a fraction. Okay? So in this example, you have a -4/5 times x equals a -8. Okay? So you're multiplying here. So you would typically divide by a -4/5 on both sides. But I want to show you something. If I take, and I'm going to do it over here, if I have a -4 over 5 divided by a -4 over 5. When we were doing our rational numbers and division of rational numbers, we talked about the fact that you had to take the reciprocal of the second fraction. So that would be a -4 over 5 times negative 5 over 4. This is the multiplicative identity, okay? And the multiplicative property, okay? Because of this, when you have that negative 4 over 5 and negative 5 over 4, you end up with a 20 over 20. And 20 over 20 equals 1. And then if we multiply anything by 1, we're going to get that answer. So the reason we do this, or the reason I wanted to show you this, is because right here, that multiplying by the reciprocal, instead of dividing when you have a fraction, you are going to multiply by the reciprocal to get it alone, because that's what you have to do anyway. So it essentially saves you a step. So when you have a fraction, negative 4 over 5x equals negative 8, you're going to take a negative 4 over 5x, and you're going to multiply that by negative 5 over 4. You're going to multiply it by the reciprocal, okay? And then you have to multiply the other side because we got to keep it in balance so our teeter-totter doesn't go off kilter. So if we have a negative 8, you're going to multiply that then too by a negative 5 over 4. Okay? Over here, I just showed you what it looks like. That ends up being 1, and 1 times x is x. Okay? Now we have to solve this problem. So a negative 8 is a negative 8 over 1 times negative 5 over 4. So you can cross simplify and say, okay, 4 can go into 4 one time, and 4 can go into a negative 8 a negative 2 times. Okay? Then you have an answer of a negative 2 times a negative 5 is going to give you 10 over, and 1 times 1 is 1. So that equals 10. So when you multiply that out, that's how that work should look. And you're showing that work, that multiplication of fraction. And you end up then with an answer of x equaling 10. Now again, if you wanted to check that, you could take that and plunk it in here, and you should get the same answer. Okay? All right, I would like you right now to pause your computer, and I would like you to do number 4. I would like you to do number 4, please, and then come back. Okay, number 4. Number 4 is a negative 14 equals 2/3 x. So to solve that, I have to multiply both sides by 3 over 2, because I need to get that variable alone, and I take the reciprocal because of the multiplicative inverse property, okay? That multiplicative inverse property says that if you multiply by the reciprocal, you will get 1. So this then equals x, okay? Now on this side, I have a negative 14 times 3 over 2. Well, if I turn that negative 14 into negative 14 over 1 and multiply that times 3 over 2, now I can cross simplify, because this 2 can become a 1, and then this negative 14 becomes a negative 7. Then I have 3 times a negative 7, and that's going to be a negative 21, and that would be over 1, so it would equal just a negative 21. And again, to check that, you could take that and plunk it back in here if you want. Okay? You would get the right answer. Now, oops, I went to the wrong x. Sorry. To this one. There we go. If you have any questions, or if you got that wrong, you need to go back and rewatch the video so that we can make sure that you understand it. Okay? If not, you can go on. So this next problem is using multiplication and division equations to solve real-world problems, word problems. So this first problem says the record low temperature in Arizona is 1.6 times the record low temperature in Rhode Island. What is the record low temperature in Rhode Island? Now, we talked about this yesterday in class, or the other day in class. This times means that you are going to multiply. That's what that means. So you're going to multiply. Okay, so it says that the first thing I would like you to do is to define your variable. We talked about that in class as well. I need you, when you have a word problem, always to define your variable. I want to know, what does x equal? Okay, you have to do that. And I want these, this list written down. The second thing you would do then, after you define your variable, is you would create your equation. And you should look at the words, that list of words we created in class. And that might help you if you need that to help you. Okay? And then the third thing you're going to do is solve using balanced equations. Using balanced equations and inverse operations. BEIO. And then number 4, the fourth thing you're going to do is label and check your answer. Oops. So you can see here the equation they created, 1.6 times means 1.6, and then they created a variable, the record low. We don't know what that is, the record low temperature in Arizona, because x equals the record low, or T, they told you right here, is the record low temperature in Rhode Island. So it's 1.6 times T equals -40. You divide both sides by 1.6, you end up getting your variable alone. So number 7, then I would like you to do. Pause your computer and do number 7. Okay, number 7 says the record low temperature in Hawaii is -15 hundredths times the record low temperature in Alaska. The record low temperature in Hawaii is 12 degrees Fahrenheit. What is the record low temperature in Alaska? So again, you're going to be timesing. So your variable x is going to equal the record low temperature in Alaska. Okay, now you have to create your equation. So a negative 0.15, 15 hundredths, times x, because that times the record low temperature in Alaska, equals 12, which is the record low temperature in Hawaii. Okay, now we need to get that variable alone. So I created my equation. We got to get the variable alone. So we're going to balance our equation because we're going to do it to both sides. We're multiplying here, so we divide. So we're going to divide by a negative 0.15, or 15 hundredths, negative 15 hundredths. Okay, now over here on the left, negative 1.5 over negative 1.5 equals 1, and 1 times x is x, equals 12 divided by a negative 1.5. If you put that in your handy dandy calculator, you would find out that your answer is a -80. And you have to label it, so it's degrees Fahrenheit. It's a terrible degree symbol. Degrees Fahrenheit. And then to check it, you would take this and plunk it in for that. So it's a negative 0.15 times -80. And if you, if you multiply those out, you will get an answer of positive 12. Okay? So you know you did it right. That's what you should do for every single word problem with real world story problems. That's what I want to see. Define your variable, and then create your equation, balance your equation with inverse operations, and then label your answer and check it. Okay, so what I would like you to do for tomorrow is I would like you to work on the practice problems, and I would like you to do practice problems number 7, 17, and 27. 7, 17, and then all the way down here, number 27. I want you to do a word problem, okay? 7, 17, and 27 for tomorrow. All right?